IoT Paper 2 revision. Compound interest. So, for any percentages question, we use the same formula. New amount equals original amount times by a multiplier raised to a power of years. So in this case, we are looking for the new amount, and that will be found by taking the original amount, which is £800. The multiplier, if it's a 5% increase, then the multiplier will be 1.05, and it says after 3 years, so it will be to the power of 3, and then we can just type that in on the calculator, 1.05 to the power of 3, and we get £926 and 10 pence. Be careful with what the question asks for, how much money is in the account. This is how much money will be in the account. If it was just interest, we'd have to take the original 800 away. So business declares that its office furniture is depreciating. Again, the same formula, new amount equals original amount times by multiplier to a power of years. We are trying to find the new amount. The original amount was this 35,000 we started with. This time, if it's decreasing at a rate of 18, the multiplier will be 0.82, and it says 3 years, so again it's power 3, and then we just plug that into the calculator, and we find that it is £19,297 and 88 pence that it is worth now. Sally invests £2,500 for 2 years at 7% compound interest. What is the value after 2 years? Exactly the same formula. So again, the original amount this time 2,500. The multiplier will be 1.07, and for 2 years, so power 2. And we get the answer 2862.25, and that is how much it is worth. Again, depreciation, same formula. So £800 to start with. 5% decrease means it's going to be a 0.95, and this is a period of 2 years, so it's squared. So it is worth £722 at the end of those 2 years. New amount equals original amount times multiplier to the power of years again. So this time we're starting with 6,500. It's depreciating by 12%, so that's a 0.88 multiplier, and they are talking about 2 years. And then we just type that into the calculator, and we find that it is £5,033 and 60 pence. Just be careful on the calculator, this just says 0.6, but with money we need 2 decimal places. Last one of these then, new amount equals original amount times by multiplier to the power of years. So we've got 6,000 times by 1.04 to the power of 3. And we get that this is 6749.18, so £6,749.18. But be careful here, it's only asking for the interest, so we have to subtract the original 6,000 from this to find that the interest was £749 and 18 pence. Bounds of measurement. So we need to add on and take off half of the measurement that they're nearest to. Worktop Magic, 4,000 to the nearest 5 mil. So that could be 4,002.5, because we're going to add on 2.5 either way, or it could be 4,000 minus 2.5, which would give us 3997.5 millimeters. Workshop tops for you is saying it's plus or minus 3 mil. So plus 3 mil would just be 4,003, and minus 3 mil would be 3,997. Completed the table. So a customer requires a worktop to fit a length of 4.02. Would both of them be able to do it? So we need to look at what the least it possibly could be, because they could both supply it at the least. So would they be able to supply it? The answer is possibly, because the least values, neither of their least values would fit the 4.02. However, both of their greatest values would. So the answer would be yes, provided the worktops were not the least possible. So a truck can carry a load of 1,600 kilograms to the nearest 100 kilograms. As soon as you see to the nearest 100, write down what it could go as far as. So it could be as much as 1650 and it could be as little as 1550. A crate weighs 75 to the nearest 5. So we've got 75. So it could be as much as 77.5 and it could be as little as 72.5. What is the maximum possible number of crates that could be placed on the truck? So the maximum number, we are going to say that the truck can hold as much as possible. So for the maximum, the truck is going to hold the full amount, and we're going to put in it the lightest possible crates we can. So when you do that division, you find that 1650 divided by 72.5 comes out as 22.7. So obviously the 0.7 of a crate wouldn't fit, so it would be 22 crates. 100 paving slabs will cover an area of at least 43.5 metres squared. So they're measured to the nearest centimetre. So 0.8 metres is 80 centimetres. So that to the nearest centimetre would be 80.5 and 79.5. 0.55 is 55 centimetres, so that's 55.5 or 54.5. Now, one slab would be obviously these two numbers multiplied together for the area, and they're saying that it will always cover 43.5. So to make sure it'll always cover, we're going to have to take into account the smallest two amounts. Now, as this is in metres squared, I'm going to turn these back into metres squared. So the area of one slab is 0.795 times by 0.545. So one slab will cover an area of 0.433, and that we'll leave it at 3 decimal places, meters squared. So that's one slab. So 100 of those slabs would cover, times that number by 100 then, 43.32 meters squared. So we could say this is not true because obviously this number is smaller than what they're stating. Write down a maximum area that could be covered by 100. So for each individual one, the maximum will be 0.805 times by 0.555, and then we want 100 of those, so we'll times it by 100. And we find that the maximum area would be 44.68 meters squared. Changing the subject of the formula, make h the subject of the formula. First of all, expand the bracket so we've got a single line, so that's 10h minus 20e equals 7h minus 7k. Collect the h's together, so I'm going to take this h over there. 10h minus 7h is equal to minus 7k plus 20e. Simplify like terms, so 3h is equal to minus 7k plus 20e. Take the 3 over and divide, and we find that h is equal to minus 7k plus 20e over 3. Make e the subject of the formula, so get all the e's on the same side. So 5be minus 3e is equal to 7c minus 10b. Factorise e out on this side so that we get e as a common factor and then a bracket of 5b minus 3. Take this over and divide, so we get e equals 7c minus 10b divided by 5b minus 3. Make g the subject of the formula, nice and straightforward one. Take the 8 over first and then divide by 5 to get g on its own. Make r the subject of the formula, get rid of the fraction first, so we get 3v equals 4 pi r cubed. The 4 and the pi are both multiplying, so they will come over and they will both divide. So that's equal to r cubed, and then to get rid of the cubed, we need to do the cube root of both sides, and that will be r. Make d the subject of the formula, get the two d terms on the same side to start with. Again, factorise the letter we want out common, so e minus 2 in a bracket, g plus c, and then this is going to divide, which will give us d equals g plus c divided by e minus 2. Make w the subject of the formula, expand the bracket first, 6w plus 6y equals 10y minus 7. Take the 6y away, so we get 10y minus 7 minus 6y. Then we're going to divide by 6, and at the same time we're going to collect like terms, so we'll just get w equals 4y minus 7 divided by 6. Make f the subject of the formula, expand the bracket to start with. 6gf plus 12g. Get the f terms all together because that's the one we want on its own. So that's 12g plus 7. Factorise the letter we're looking for, f, out, so it's 13 minus 6g is equal to 12g plus 7. And then take that over and divide, so we get 12g plus 7 divided by 13 minus 6g. Make c the subject of the formula. To start with, I'm going to square both sides to get rid of the square root symbol. Then I'm just going to move everything away from the c, so it becomes a squared plus d is equal to bc, and then I'm going to have to divide by b to get c on its own. Again, start off by expanding the bracket. 18k minus 6q is equal to dk plus 7. Get the k term together. So 18k minus dk is equal to 7 plus 6q. Factorise the letter I want, k, so it's 18 minus d equals 7 plus 6q. And then divide, so I get k is equal to 7 plus 6q divided by 18 minus d.